So welcome everyone to the Palouse-Clearwater Food Coalition's monthly meeting. Today, we're really excited to have a focus on backyard water conservation and are really appreciative of our member Johana Doyle, who has put together today's program and is going to be our lead presenter. So I'm going to go ahead and turn over the program to Johana. Thank you.
Good morning. Thank you so much for joining me today. When I started working on this presentation, I had no idea how captivating and what a wonderful experience it would be for me. I've gotten to know new people, reaffirmed some of my experiences, and learned so much more. Today, I'm hoping to cover three topics under water conservation: drip irrigation, OLLAS, and rain barrels. I'm starting with rain barrels, but before I do that, I'd like to thank the following people for their time and support in this project. Water conservation is becoming alarmingly important as we look at places like Lake Powell, where there was a 30-foot drop in 10 months between 2020 and 2021. One solution to conserving water is to use drip irrigation. Drip irrigation is simple. It goes direct to the roots. It saves water, limits evaporation, limits weeds, and allows the creation and control of microclimates. Why not do drip irrigation? Well, it requires some maintenance. When plastic components crack in the winter, minerals can clog the drippers, and breaks in the tubing occur very regularly when sabotaged by mowers, trimmers, and aerators. An ultra simple solution using drip irrigation is to use a drip tube or drip tape. People like Deep Roots and Wingover Farms use these almost exclusively. They have pre-spaced holes in inches, so you can purchase tubing that has 4-inch spaced holes, 8 or 12, that it directly then forces you to space your plants accordingly. But in general, they're used in straight rows. It's extremely easy to do. You buy the hose, it has a spigot attachment and an end clamp. You attach it to your faucet and you're done. To build a more versatile and simple system requires a hose end faucet connector, a backbone, emitter options, and a 1/2-inch hose end clamp. To begin, you've got to buy the right hose. Black poly tubing in town is most frequently 1/2 inch, comes in 50 to 100-foot rolls. Spaghetti tubing of 1/4 inch also comes in 50-foot rolls. The punch tool is extremely valuable because it makes the holes consistent. You can see in this photo that the 1/2 inch tubing is placed right next to the puncher next to this tool. And so you have an idea of how that works when you clamp it. Adding an end emitter to the hole gives you options of how many gallons per hour you'd like to be dispersed through this emitter. Color is important. The red ended cap signifies a 1/2 gallon, the totally black a 1 gallon, and the green on the emitter a 2 gallon per hour. One punches the emitter into the hole you just created and you're ready to go. Attaching to water requires a hose end attachment for the spigot. This is a compression fitting, so you slide the tubing into the hose end. You attach a 1/2 inch hose clamp on the end, and now you have a backbone, an emitter, a hose connector, an end clamp, and you're done. You can make things more interesting and create a situation of spot watering. Adding a 1/4 inch tube allows you to go more directly to the plant. And if your tubing is some distance from the plant, this is a good option. You can get fancy and add other components to that basic spaghetti tubing. You can add a bug end cap, which is something new I had never heard of, and you can add a stake. But honestly, the simple solution is cheaper and has worked fine for me. Another way of connecting to the backbone is to use a straight barb connector. There are straights and T connectors. In the upper right-hand corner, I have come off of the backbone, as you see in the picture, with the barb connector straight and then to a T, and the two spaghetti straps, one goes to each plant. There are no fancy add-ons to that. You can go wild and string those T connectors out with more 1/4 inch tubing and address a whole area, microclimate area. The bubblers can be attached directly to the end of the 1/4 tubing, or the 1/4 tubing can be attached to a bubbler on a stake. And the stake, in some cases, makes it much easier to keep that bubbler in the position that you want it, which is upright. To hook pieces of tubing together, compression fittings are used, and color coding here is important as well. The color code of green signifies that the tubing is 1/2 inch. When buying compression fittings, it's really important to pay attention to the outside diameter readings. In this, you'll see it's a 1/2 inch tubing with a 0.62 outside diameter. These below are various ways you can use the elbows and straight connectors to modify and meet your needs. When you're buying connectors, it's really easy to make mistakes unless you are paying attention directly to the brand that you're buying. Even within the brand, it can get confusing. I use the green compression rain drip elements, and they're a 0.62. When I was in Lewiston, I saw some really great attachments for tubing that I have been looking for. They were made by the DIG company. And unfortunately, the inside diameter of these tubes is not compatible with the 1/2 inch tubing that I'm using with my black 1/2 inch black plastic backbone. So I got to return them. The female or green connectors are what I use most prevalently, but the male connectors are harder to find and are frequently a little bit easier to install. If you're grappling with different diameters on your tubing, the universal coupling makes a huge difference. It allows you to screw down tight and not pay as much attention to the diameters. Everyday mistakes can be fixed with goof plugs, which are the world's greatest invention. They have two sides. The fat end is for 1/2 inch tubing, and the tinier side is for the 1/4 inch tubing. They're really easy to install if you use a needle nose pliers, because it's a tiny element and it can get a little frustrating. You remember we created our simple run of the hose connector, the poly tubing, the 1/2 gallon emitter, and the end clamp. Well, we can considerably modify this and make it much more sophisticated and easier to use. We can add a simple minute timer, which is battery operated, an automatic watering timer, which is also battery operated and allows the timer to take care of everything. It goes on and off automatically, whereas the simple timer, you have to go out there and turn it on. You can create zones to address the individual needs of the plants that you have. And you can add Y connectors and 4 connectors, layer upon layer. One arm goes to the hose and one arm goes to the hose for the drip system. You can combine them all. In this picture on the right, I have put my first Y connector some distance from the house, because at this point it's not mounted, and every time I adjust something, it wiggles. I've got my garden hose attached on the right and a watering meter on the left. I go to 4 different zones. I've attached 2 of them. They're color coded so that I have a clue as to where that section of tubing is going to. To winterize the system, I remove the timer, any backflow presenters, filters, or pressure regulators. I remove the batteries from the timers and I store everything in the garage. I also remove all the end caps and elevate the hose ends so that the system can automatically drain. I have a neighbor whose house is on a slope, and this process is incredibly easy. When I'm concerned about the plastic connector elements during the winter, I cover them with leaves that turn into mulch over the period of the winter, or plastic bags filled with sawdust. Things happen. For example, the lawnmower goes by, or the aerator turns the black tubing to shreds. Burying the tubing makes a significant difference, and covering it after it's buried is also useful. It's recommended not to over tighten any regulators or elements like the timer in the assembly of your system. Hand tightening only is recommended. It's easier to punch holes in the 1/2-inch black tubing when it's cold. When it's warm, it wiggles out of the way. On the other hand, it's easier to attach the compression fittings and emitters when the tubing is warm. Leaving the poly tubing in the sun makes it much easier to manage. It wants to return to its original rolled up shape. When it's warm, it's much more willing to express itself in a straight line. This tool is a multi-purpose tool. It cuts the tubing and allows you to use that funny looking hole there at the end to hold the emitter and push it into the black tubing. That saves sore little fingers. By the time you do a little bit of this, you will find that you have an incredible amount of chaos. Hose ends, emitters, plugs, faucet connectors. And this has, putting it in one place has really helped me. Hang on one second. I'll see if I'm at the end of my run here. Does anyone have any questions or things they'd like to share about their experience using drip irrigation?
Candace is asking, what is that tool called? And I believe she's referring to this green tool.
I don't know what the tool is called, but it's very clear. It's about 10 inches long. And if the store has it, you'll know.
If anybody else knows what the name of that tool is, please go ahead and unmute and jump in.
One of the things I found about that tool is that it punches a much smaller hole than the previous blue and white tool that I showed you at the beginning of the presentation. The bigger the hole, within reason, makes it easier to press the emitter into the hole. Too big a hole, of course, leads to leaking, but I find it extremely difficult with the hole punched by the green tool to get that emitter in.
I just did a quick Google search and it seems like a lot of them are just called drip irrigation hole punches or irrigation tubing hole punch. So I think if you ask someone at a store that, they'd probably get you where you needed to go.
Yeah, I have found most of these things locally in our hardware stores.
Great. Johana, if somebody's thinking about planning out their system, how would you recommend they go about determining how much tubing they need and designing out their connectors and the like? Is that something that you would map out initially, go out in your yard, do some measurements? How would you recommend?
I think you've touched on an incredibly important element, and that is that planning is important. And taking advantage of the lay of the land, if you will. So taking advantage of downhill slopes can make a huge difference in the winter when you're trying to winterize your system. I draw sketches of my lot, and then try to find out the most efficient way to get the water where it's going using the least amount of connectors. I've found that the connectors are the weak link in the system because they're most likely to crack and need to be replaced. Also, starting out small with as simple a run as possible makes a huge difference. It's easier to put together, you're less likely to make mistakes, and you get a rather instant result. And then it's easy to add Y connectors and T connectors to change your mind and expand your system.
I have a system that is similar to this. It's almost 20 years old, and I have not had to replace my 1/2-inch tubing. I have had to repair because, as you said, like I might have gotten it buried and then I'm out like working in the garden and I cut it, or I might have to decide I've put in different perennials and now I have to rerun the 1/4-inch tubing.
Mm-hmm.
One thing that I have found, and my husband and I are not good at, is actually taking off those emitters. And so every year, that's, I think, our major expense is for us to replace those emitters because we haven't thought about taking them out. And also we have a flat yard and we have one water source that feeds all of our system. So we have SYG come and actually blow out our lines at the end of the year. And that does cost about $65 for them to come and do that winterizing of our system. But that's another option if you don't have slope or the physical ability to actually take your system apart and kind of do that winterizing, is to have a landscape company come and do that.
That's a fabulous piece of information. I didn't know there were companies that could blow out the system. I'm curious, you said it's hard to take out the emitters. What
No,
exactly?
I said that we don't take them out. Not that it would be hard, but we hadn't thought about taking them out. So for us, that's the major expense, is that every year a number of those have gotten clogged or buried, or quite frankly, the dog has chewed the head off of them. And so we have to go around and sometimes restring the 1/4-inch tubing, but most often we have to change the emitter at the end.
Interesting. I've found that the more complicated the emitter, if it's a mister or a bubbler, they're the most likely to have problems.
Yes. And we do use the emitters that are the misters so that we can have, we can do the full round, we can do half, or we can do 1/4 to try to get the best area that we can for the beds that we use this system in.
And it sounds like you use zones as well.
We have the capacity to do zones, but because we're coming off of one system, we have our line. We have one main line that goes through the majority of the gardens, and then it's buried in the grass between the garden spaces. Mm-hmm. And so we actually have not used the zone feature because of the way it was installed and how it snakes through. And we're in town, so we actually have good water pressure to actually cover all around the house and through all the major beds in the backyard. We have a couple more questions that have come in. Ashkan is asking, why shouldn't Teflon tape be used?
I honestly don't know, but I suspect it has something to do with the way the water pressure affects I don't know, but again, my guess is that as the water goes through, it pressurizes the system in some way that seals up those connections. And I have been confused by that in the past and over tightened my flow regulators and so on. Now that I understand, I'm not doing that.
We have a question from Candace as well. Are there guidelines on how many feet of 1/2-inch and 1/4-inch tubing is optimum before you need to create another zone?
I'm sure there are, and I have never paid any attention. And I'm amazed at what I get away with out of my house water faucet.
Great. Roy says DripWorks Company is a great resource for layout and flows and such.
The resources on the web are remarkable. The Rain Drip company, which is most of my equipment, has excellent information on its website as well.
Thank you. Any other questions before we go on to the next backyard water conservation system?
Okay, on we go to OLLAS. OLLAS are unglazed clay pots. They originated in Northern Africa, and there's evidence of their use 4,000 years ago in China. They're still used in India, Iran, and Brazil, and local craftsmen make the OLLAS, making this a self-supporting system. How do they work? They're buried in the soil and filled with water. Dry soil outside pulls water through the porous unglazed pots, and the roots as well pull water out in response to evaporation through the leaves. The roots of the plant eventually grow toward and around the OLLAS, allowing for consistent watering. The rate is influenced by the needs of the plant and the season. And if the soil is moist, the water stays in the pot. So we're meeting the needs of the plant. They are almost evaporation free, particularly if you put a cap on the top. A commercial size OLLAS, which is shaped like the one on the right, and a 3-gallon pot will water a 3-foot diameter circle. An 8-inch flower pot that you can buy at any local store can water plants within a 16-inch diameter. The lids decrease evaporation, and you see a commercial pot there with a lid on top. The effectiveness of the OLLAS depends on the effectiveness, and the optimal spacing of OLLAS depends on the soil type, plant types, and climate. They're easy to make yourself. What you're seeing at the top is a plug to fill the hole of the bottom pot. That's the inside of the plug, which is put down with Gorilla Glue. And on the outside, I sealed it with more Gorilla Glue, so I know there's no water loss through there. I stacked 2 3.5 pots together, and I've discovered that they hold 1 liter of water. An 8-inch pot holds 1 gallon. So if you stacked 2 8-inch pots, you'd have a 2-gallon capacity. You can see how I figured out what the capacity of my 2 3.5 pots was. I have looked at many options in my garage for leftover items to figure out ways to cover the hole in the top. You have to remember not to close over this one as well. And I use some PVC pipe and a top from a spice jar to create the plug for my system. My experience, and the water meter, the moisture meter is the neatest thing that I have found in my recent exploration. By using that, I was able to tell that although the surface of my planter looked dry, 2 inches down, the meter was reading that there was moisture. I have had that planter set up for about a month. So it went through nice, warm, windy weather, and it went through the snow that we had. I'm glad to tell you the flowers survived. And over 1 month, there was 1 inch of water left in the bottom. Now, obviously, that's related to the time of year and the climate conditions at the time. In my readings, I find that they're particularly well suited to tomatoes, squash, and melons because apparently they develop a deep root system that encapsulates the OLLAS itself. So they're directly attached to the water source. What you see here is different options. In the second photo from the left, they've placed several OLLAS in a half barrel, whereas the tomato plant on the right has only one. The disadvantages is that it's highly likely these clay pots will break over the winter, but keeping them in soil and covering them with mulch should limit that problem. Apparently, after 5 years of use, mineral deposits may limit the porosity of the pot. Heavy soils may make them less effective. And when you transplant plants or start new seedlings, they recommend that you place them directly next to the OLLA to speed up their adaptation. And it's necessary with seeds and transplants initially to water them by hand, if you will, rather than rely on the pot, because the root system is not well enough established to take advantage of the setup. Okay. Any questions on this or things you'd like to share about your experience? This is my discovery from this year, and I'm really excited to see what happens with it. I had a terrible time last summer keeping my pots watered. And I've read on the web that people frequently attach their drip irrigation system to these OLLAS to fill them automatically, which may be useful. So that may be something I try.
That's an interesting idea. I was wondering about even small corks being able to plug those holes that you need to refill.
Yeah.
Taking
the hole on this 3.5-inch pot is very small, so I use a funnel, but it wouldn't matter if you had overflow. It's just less efficient, and I'm impatient.
Does anybody else have any questions or any experience with OLLAS?
All right, well then let us go on to barrels and cisterns. The whole point of which is to recycle rainfall. The benefits of recycling rainwater include limiting pollutants from flowing into rivers and city water systems, reducing demand for treated tap water, and controlling erosion and moisture accumulation near foundations. Rain barrels and cisterns are very similar. The difference being you can collect more in cisterns, and frequently they're below ground, so you need a pump to get the water up out of the ground. The key element of rain barrels is having sufficient pressure to move the water out of the spigot hole. Here's a variety of setups: single barrels, direct from downspouts, or in the case of the cistern, and what I want to point out here is that the brown barrel is on an elevated platform, and those elevated platforms are terribly important for the gravity feed, and they need to be a very secure base. Clearly, the cistern on the right has a wondrous base that we would never worry about. But the weight of water in a 55-gallon drum is 500 pounds. So you can see why that base of support that supplies the elevation for the pressure is critically important. Jean Leffingwell has this 550-gallon cistern. It takes advantage of a tin roof, which is the ideal. It's gravity fed. It has a solid elevated base, and it attaches to a hose that she uses on her raised bed just around the corner. Zena Hartung has a different approach. When she bought her lot and decided to build a new home, She wanted to save water runoff and use it as an auxiliary water source for the front and side of the house. Her system funnels all downspouts to a single outlet, leading to a 2,200 gallon concrete cistern, which captures the water. It's directly below the raised bed on the right. Water is pumped to a frost-free faucet, and excess water can be directed to a rain garden. As in her words, in a 100-year flood, if there is more water than the tank and the rain garden can handle, then we can reroute back to the city stormwater, which is, I think, a very unique solution. Pressure from the pump is not sufficient to support a drip irrigation system, so they use a separate system using city water. Her rain garden for excess water allows the water to pass through a system of deep-rooted plants. The plants filter pollutants from the roof runoff. They recharge the groundwater, and they reduce mosquito breeding, which is one reason one would want to have a closed system, even in the barrel setup. In Zena's words, water flows from the cistern overflow pipe out into the lined creek bed and around the house under the walkway from the backyard and into the garden. The lined creek bed is what you're seeing here in the downhill slope covered with rocks. The base of that is old carpeting, then a layer of visqueen, and then large rocks and gravel on top. Around the rain garden, I planted thirsty native plants, elderberry, golden currants, black hawthorn, and 2 kinds of willows, 2 alder trees, and a red ostia dogwood. It will look so much better by June. The base of the rain garden has leaf mold. The sedges are expected to eventually grow into it. I'd hope to start some cattails too. We shall see if it is wet enough year-round to keep them growing. I usually blow the leaves and stuff out of it just before the next wet season. These are the elements of her setup. The cistern is located under the raised bed planter on the right. The switch for the electric pump is mounted on the side of her house. It supplies water to the frost-free water pipe. The level of water in the cistern is monitored through the barrels at the bottom. That is the same barrel, excuse me, just different views. And the reroute water to the city storm system is located in the barrel at the bottom of the raised bed. Kathleen Burns also has a cistern, but it's entirely different. If you were to visit Kathleen's house today, there would be nothing to see. She has a buried 1,500 gallon cistern, and she has a 2-barrel system on the barn. What's different about Kathleen's system is that it is rated for drinking water, and it's made of plastic, not concrete. She uses a submersible tub, a pump, to draw the water up to a hose. And she waters her fruit trees in the early spring through July or early August. That's how much capacity she gets out of that 1,500 gallons. Pressure from the pump is not sufficient to support a drip system, so she has a separate drip irrigation system. She has a 2-barrel system. These pictures do not represent her actual system because it's already been put away for the winter, which we'll get back to. So I, of course, got pictures from the web to represent what she explained to me. Her 2 barrels are located right next to each other in a stacked scenario. This creates more water pressure and collects more water. She uses a hose from the spigot to water her pots, and she tells me that one good rainfall fills both barrels. According to her description, she has a top of barrel entry for the water from the gutter, and a debris screen filters out particles. You don't see anything at Kathleen's house right now because she has a winterization plan for her barrels. She drains and disconnects the barrels. She uses vinegar or baking soda to clean them for algae and or mold. And she reconnects the barrel parts and stores everything in the barn. So in the spring, she's ready to connect to the gutter and she's set up. Her winterization plan for the cistern is to remove the submersible pump. Okay. Now we're up to, does anyone have questions about those setups before we move on to just the barrels?
I have a question, Johana. Do you know if there's any type of permitting that the city requires to have a cistern or a rain barrel system?
I do not about Idaho. I do know that in Washington, there are some restrictions and one should be informed. If you're a renter, of course, you'd want to be talking with the owner of your land. That's really all I know about that. I think rain barrels, at least the smaller rain barrels, the small edition, are becoming increasingly popular, and I'm surprised I haven't heard anything. But of course, Idaho tends not to have too many regulations.
That's right. Great. Okay, we have a couple of questions that have come in. Teresa asks, when does Kathleen set the barrels back up? And how much frost can they tolerate?
I don't know when she does because she's in Arizona and we didn't cover that conversation. But clearly there are people who leave their setup open all year round. So I don't, as long as it's disconnected from the water source. So it's empty during the winter, there really should not be a problem.
Thank you. Zena says that she has a brochure that's available from the Moscow City Water Department. So that's a good resource to know about. And Roy says that this must, in terms of permitting, that we don't need them in Idaho as long as the water is gathered before it enters a natural stream.
Interesting.
Great. So thanks, Zena and Roy, for letting us know that information. Any other questions? Okay, I think we can go on to the next piece.
All right. Now, just addressing the barrels. Jody Prout of the Palouse Conservation District puts on a rain barrel workshop that benefits Whitman County residents. It's also limited to Whitman County residents. This is supported by the River Network that collaborates with the Coca-Cola Company, the Coca-Cola Foundation, and hosts local organizations across the United States. The information that follows was gleaned from Jody Prout's presentation, research on the web, and discussions from local residents. I have not built a rain barrel, but this is what I learned. Select a flat location within 3 feet of the downspout. Constructing a sturdy stand is critical, and the barrel itself needs to be elevated at least 10 inches high to support a gravity feed to the spigot. Purchasing a kit makes things easier because this kit includes everything, including the drill bits that you need to install the various elements. Or you could just go buy the barrel, the whole thing set up, installed, and just install it into the gutter and ready to go. There are multiple resources on the web, the Rain Barrel Depot and Earth Minded, which sells rain recycling kits and parts. The Chattahoochee River Keeper and Rain Cycle rain barrel kits are another option, and they have a video on YouTube. But there are many videos on YouTube. You almost fall all over them. In the construction process, the first step is to drill the spigot hole. You'll notice this gentleman is taking advantage of a stabilizing device while he drills his hole. It's put about 2 to 3 inches above the bottom of the barrel, and the bottom is the rounded part, because this does get confusing as one talks about the different holes. A seal is inserted into the hole, and then a spigot is hand fitted. As a personal experience, the lever type on-off valve is a much easier unit to manage than the round spigot. There are two types of fill hole systems. One is the top hole variety, which is very simple. And the other is the side hole variety, which takes a little bit more thought. Both devices need to have some kind of device to get the water from the downspout into the barrel. Positioning the barrel on the barrel stand that you made to the downspout is super important. Measuring the height of the water entry hole on the top of the or side of the barrel and coordinating it with the hole on the downspout, it takes a little thought. Then drilling the hole in the gutter, squeezing in the adapter, making sure it's in the right position and screwing in two holes. And that part of the problem is solved. What's rarely mentioned on the web or any place else is water overflowing out of the barrel. So it's easy to imagine the overflow options during a big storm. Where does all that water go? Once it overfills the capacity of the barrel itself, it needs a way to be dispersed. In the PVC option, it has a nice overflow pipe. And in the single barrel downspout, they've used a hose connected to the barrel. And you can buy the overflow kits separately. Maintaining the barrel means keeping it clean, rinsing it out occasionally, using a non-toxic solution of vinegar to remove and limit sludge, algae, mold, and mildew. Winterizing means deconnecting and draining. Disconnecting meaning from the downspout and draining the barrel and leaving the spigot open. This should preclude any problems with freezing. Flipping the diverter, all the diverters are a little bit different. In some you literally uninstall, and others you just flip the diverter sideways from 180 to 90 degrees so that the water stops filling into the barrel. And in cases like Kathleen, you store it inside. Oh, questions or short stories you would share with us?
Great. Thank you, Johana. I think we can stop sharing your screen unless anybody has a specific question that we need to go back to look at any of the devices that Johana presented today. I see that we have a few people clapping, but not any requests to see any devices. So are there any questions to start out with or observations that anybody wants to share from their own systems?
I just wanted to make a comment that when I built mine, we had a lot of luck finding different supplies at like the Habitat for Humanity building stores, and it like used, or yeah, just other building supply stores that reuse items. So that's a good place to look if you're on a tight budget too.
That's a fantastic idea.
Yes, and we do have a Habitat for Humanity store right here in Moscow, so great idea. Cynthia says super info, thank you. Allie, when you built yours, I'm assuming you're talking about building a rain barrel. How did you deal with overflow, or was that even an issue in Missoula?
It really wasn't an issue. We did try to kind of like time it correctly by hooking it up right as the snow was melting, and it would get close at times. But we also had a pretty big yard with different trees, like plum trees and stuff like that. So we just kind of monitored it, and when it looked like it was getting close, we just poured water somewhere or reused it in some way. But yeah, it wasn't a super like specific system. We just kind of drained some water and put it somewhere useful when we saw it was getting close.
Okay, thank you. Anybody else? Oh, go ahead, Francis.
This is Francis, and the diverter system that we use, the overflow just goes back into the downspout, and then there's a drainage field that all exits out to. So the diverter from the downspout and the system we have just takes it right back in. Does that make sense for overflow?
It does. That's a really great idea.
Wow.
And Francis, are you having any times that you really see that your system is maxed out? Does that happen a lot here on the Palouse, or not a lot?
So certainly not in the last 3 years. We haven't had any maxing out of the system at all. We just aren't getting the rains like we used to get. It used to be so we swapped the diverters we were using, that sometimes our diverters slowed the flow down the downspout. And so up at the gutter area, if there was too much runoff, then we would get runoff over the gutters. But we adjusted what we were doing for how it downspouts and took care of that. And then we haven't had our rains. Sorry.
Right. That's true. The runoff was one of the things that I was thinking about. Like for my house, I have a lot of tree cover on the house, and it seems like a constant chore to be cleaning out the gutters. And I'm wondering a little bit about the whole screening process and what kind of maintenance that would entail depending upon what type of tree cover you had around your property.
There on the web, they advertise some filtering systems that you can put in the downspout above the diverter. I suppose they're worth a try. I wonder though, with a lot of debris coming down those downspouts, how effective they would be, or if they would not get clogged up as well.
So the answer is they're very effective.
Wow.
And that they will get clogged over 2 or 3 years, depending upon how much leaf litter and wind and little twigs you have that would otherwise be in your gutters. But anybody who checks their gutters every year or two to see if they're clean isn't, I don't think, going to experience an issue. We only had to clean at one area under a cherry tree after probably 10 or 12 years of use. And so we just removed the screen device, thoroughly cleaned it, reinstalled it.
Fabulous.
Okay, great.
Yeah, mine was located under a bunch of pine trees. So we had a lot of issues actually with pine needles. And they wouldn't really go through the screen unless like the angle was perfect, but for the most part, we did have to go up there we went like every couple months and just kind of looked and wiped away anything that was in front of the screen. But we were also lucky that our roofs were really low. It was a single-story house, so it was not that hard to just grab a 10-foot ladder and look at it. I could see it being a bigger issue if you had a 2-story or really tall house.
There are flat screens, and then what we have, it angles up like a teepee before the screen top over the part where it goes down. And so those flanges on either side would, well, we don't have pines, thankfully, but but they stop just an awful lot of stuff. But your pines would definitely back up there, and then you'd get some runoff over the gutter to alert you that you would need to clean those needles.
Linda says that she set up her barrel easily that she got from the Palouse Conservation District, and that all the pieces necessary were included. She's excited to see how it does. And I see that Jody is actually on today's program. So Jody, if you have anything to add, please feel free to jump into the conversation.
The program that we offered was kind of a one-off, a great way to offer this practice. And yeah, it was sponsored by the Coca-Cola company. So we're hoping to do it next year. Unfortunately, it is only open to Whitman County residents. But it was great. A lot of things that have been mentioned here already. The diverter kit has that built-in diverter to stop overflow. So that's a great feature. And normally those are about $35. So very reasonable. Another tip that we talked about for debris getting into the kits was doing pantyhose on top of the entry from the exit from your gutter into the rain barrel, and that just keeps out that sediments or debris that would be coming off of your roof from entering into your rain barrel. Obviously, that needs to be cleaned, but another simple solution. So it's a new program that we've been experimenting with, and we're still learning a lot. So, so this is really helpful to hear what Johana presented on.
Great. Thanks for those tips. Johana, Patricia is asking if the PowerPoint will be available. Is that something that you would be willing to make available? We can put it on the Food Coalition's website if that works for you.
Sure, that would be fine.
Okay. We will put it on the Food Coalition's website as well as a link to this recording.
And of course, you'll show me how.
Yes, you can just send it as it is and we will save it as a PDF for you. Ashkan says that another advantage of rainwater is that it has an acidic pH, which is great for the soil and plants. The rainwater is also an excellent choice for watering houseplants.
Interesting.
Well, I really want to thank you, Johana, for your presentation today. I am inspired to think about those OLLAS and whether or not that is something that I can fit in specific places in my gardens and my rain barrels, because that's a challenge when I travel, is being really worried about particularly my rain barrels drying out, because I have a lot of herbs in there and they tend to dry out quite easily. So I'm really excited about that option. Thank you everyone for joining us today. Next month, during our third Thursday conversation, we are going to be learning about the Latah Community Kitchen and the Peterson Cookhouse, two commercial kitchens that were created with a lot of input from Palouse-Clearwater Food Coalition members and are available to the community. So we'll have an overview of each of those kitchens, the equipment that's available, and how it works to be able to rent and use those facilities. So if you're interested in any type of value-added products or even doing some larger canning projects or canning with your friends, this would be a great presentation for you to come to. So thank you again. We hope you have a great month and we look forward to seeing you in May.